So first of all, thank you also for joining us on this session. It's not for granted for all of you to be here. And I'm really excited to talk to you about CNAPP. Show of hands, I don't really see the audience, sorry, but still let's try. Show of hands, who here has heard of CNAPP? Okay, some people have those. How many of you evaluated CNAPP solutions? Adopted, implemented CNAPP solutions? All right, so I think most of you are in the right place, because today what we're going to talk about is CNAPP as a technology. And what it really is, so the acronym is Cloud Native Application Protection Platform. And what it really is, it's a very important piece of technology, which is a platform for securing cloud environment. So first of all, my name is Lior. I'm Director of Cloud Security Advocacy for a company called Tenable. Who here has heard of Tenable? Okay, what have you heard of Tenable? Just okay, I can really hear the audience as well. Okay, so Tenable specializes in exposure management, and one of our components of managing that exposure is, of course, in the cloud. We're going to get to that in the end of the presentation. But what we're going to talk about today mainly is, first of all, the security of the challenge of securing the cloud. Then we're going to talk a little bit about Tenable Cloud Security, what it is, how it works as a solution, as an overview. And the main part of this presentation is going to be the 10 steps, as I call it, and we're going to explain why the steps are in quotation, for a CNAPP approach. And then we're going to conclude. So first of all, just a bit of background, because the cloud, when it emerged into our lives, actually presented us with a few challenges when it comes to securing it. So first of all, there are new attack vectors compared to on-prem technology. And also, the cloud hasn't been around forever, right? It hasn't been around for 40 years, that you have a culture of massive amounts of people that have been doing it for 10 or 20 years even. These kind of people are very, very hard to come by, especially compared to how much cloud needs to be secured. Now, there's also a lot of tools, right? The industry is very much active in providing us with tools that gets kind of overwhelming, if you think about it. If you don't have a clear strategy as to what you want, you always kind of find yourself, trying out the new shiny thing, implementing it, kind of finding out it's not really doing what you expected it to do, and you kind of get a set of tools that you don't really know how to operate. And what's interesting about the cloud is that it requires intense collaboration within your organization. A lot more people are involved because they have the access. That's a good thing and a bad thing, which really leads me to talk about both the opportunity and the threat when it comes to security in the cloud. And that comes from the fact that, first of all, a lot of things are now very much accessible, right? Configurations and logs, they're very much at our fingertips, and we can also approach them programmatically in a very structured way. Now, on top of that, as we mentioned, more teams are involved, which has huge potential when it comes to operations, but also for security, because you can delegate. You can make people who run processes and run workloads be responsible for their own security, right? That's what we kind of tend to think. But the threat comes from those exact same things, because now we have more hands in the cookie jar. People have, and rightfully demand, more access, and that gets kind of hard to manage. The environments get super dynamic, right? They change very frequently. And also, they're very much susceptible for mistakes, right? You put a character in the wrong place, and guess what? A workload now has access to a bunch or even all the resources in your environment, right? And that's something to put in mind. Now, Tenable Cloud Security as a solution actually comes to leverage the opportunity while mitigating the threat in the way that it works. So as a CNAPP platform, and hopefully by the end of this presentation, you're going to understand exactly what CNAPP means and how it operates. So as a solution, it integrates with your cloud environments, of course, AWS accounts and also from other CSPs, but it also integrates with other technologies, with your identity providers, with your CI/CD pipelines. It also integrates with a bunch of third-party tools that are relevant for creating seamless experiences, and we're going to talk about that as well. And it takes all that information, everything that it queries, into one place, analyzes it, and presents you with a single pane of glass that allows you to control, manage the risk of your environment, and also be able to remediate it, right? And what we're going to do today is we're going to talk about Basically, three things, if you want. We're going to talk about knowing what you have in your environments and what are the stakes if something goes badly. We're going to talk about exposing the risks and the problems and the issues that needs to be fixed. And then we're going to talk about closing the problems, right? If we want to go to a really high-level abstraction, that's what we're going to talk about. Because as security professionals, you have very limited resources, and you have to mitigate a lot of threat. And prioritizing and understanding exactly what needs to be attended to is very crucial. So really, Tenable Cloud Security has a bunch of abilities that are in that slide, but we're going to go over them deeply over the next hour or so. So we're not going to get into that here. But the idea is that that's the process that we're going to go over. Now, the way it's going to break down is we talk about the 10 steps. And the reason why it's in quotation is that it's not really steps, right? We're going to go through a journey as to the different components that there are in this platform that is called CNAPP, right? The platform that is used in order to manage and mitigate the risk of your cloud environments. But it's not a linear process. That is, if we break down the steps that we're going to talk about today, and we're going to think of it as the know, expose, close, and also on the y-axis, you have sort of like an abstraction of the level of maturity in your organization. So that could be a nice way to look at it, like what do you do in what step? And if we look at it as a journey, right, this is the order in which we're going to talk about, then it might look like this, right? So we're going to have a talk, and it looks like really this nice little path. But reality really doesn't work that way. Because in reality, what it might more look like is something like this. Right, you go from one place to the other, and you manage a lot of different things at the same time. And as we know, in cybersecurity, a lot of the times, we kind of feel like bouncing or juggling balls in the air. And it really isn't a linear process, right? Because you're going to do the things, maybe even at the beginning, and you're going to revisit them. And you're going to have to do it continuously. And revisit and revisit and revisit because your environment changes, and things happen. And that is a very, very important thing to keep in mind, right? However, what this will do is give a very nice abstraction of the various components that are meant to be attended when it comes to securing your environment. So let's get started. We really do have a lot to unpack. So now the first thing is visibility, right? It's a very, very clear thing to understand because you can't secure what you can see. Now, the way it's going to work, as it's all the different components that we're going to revisit, is we're going to describe what is our goal in accomplishing in that step, and then we're going to exemplify how our solution actually treats it. So the first step is gaining visibility. Now, the main thing about visibility, or the structure of resources, is that this is really where your security begins. Now, show of hands, who here has a single account architecture in their environment? Good, very good. So hardly anyone ever implements a single account architecture because a single account is, of course, not a very good thing. So most of you, I assume, use AWS organizations, and this is really where security starts, in the way you structure your resources based on accounts. So as you all know, AWS resources, there's the management account, which I hope everybody's using simply for management and nothing else. And really structure your account in a clear strategy, right? There are many kinds of different approaches. It can be per application. It can be per application and per stage. It can be per application and per team, per utility. There are many ways in order to structure your OUs and your accounts, but this is really where things start. If you structure it correctly, then you can apply policies in a good way. You have a natural IAM boundary between accounts, which is very, very significant. And the next step would be to actually create visibility into those accounts. And the way it's done is by onboarding those accounts into the platform, because the platform needs to integrate with your account. Now, Tenable Cloud Security is a SaaS solution. That is, it works, as you may guess, with an IAM role in each account. And the nice thing is that you can add your entire organization with just one setup. Right? You just configure the organization and you integrate it, and then you just make sure that a role that meets a certain standard is in each account, and then the accounts are all onboarded together. right? So as long as you make sure that the proper role is in each account, then there's integration with all the accounts in your AWS organization. This is very important. Now, another thing that we're gonna release very shortly, and it's something that is very much in high demand, is actually something we call projects, which are different views of what you see in Tenable Cloud Security based on what each team needs, right? So in your organization, you have multiple teams, and those teams have different needs, and you want to compartmentalize the information because the sensitive information that you have in your security platform obviously doesn't need to look the same for everyone, and the access doesn't need to be the same. So you're going to be able to actually create separate views based on a pinpoint selection of accounts or OUs. And that's something that's coming up very shortly. Now, not just understanding what resources exist, and this is where it kind of gets a little bit more complicated. Your platform that analyzes your environment also needs to be able to show you clearly the relationship between resources. And that, for example, gets very important when it comes to security groups and the EC2s to which they apply, right? Because you want to understand, it's a very important part of your security, as to what access exists to each EC2. Another thing is if you have a KMS key, you want to understand what resources it used to encrypt, right? So you got to see it clearly when you look at the resource. Another thing, if you have a load balancer, you need to understand what targets it's aimed at. If you have a model, for example, a Bedrock model, an AI model, you want to understand where it does its training and where it shows its output. If you want to protect, for example, from things like model poisoning. Now, probably the most important relationship, and we're going to discuss that extensively, is CIEM, right? When you have resources that eventually can perform actions, such as workloads, then they have identities which they use, and those identities have access to resources. And that is a very, very important mapping to be able to do, and you got to get that out of the box. Now, you also got to be able to have deep inspection of resources. So for example, who here use EKS? Kubernetes in a different way. So Kubernetes, of course, is a very interesting and a very complicated service, and you got to be able to see the different kind of resources in your cluster in a very approachable way. And when you choose, for example, a component within your cluster, you need to be able to get all the information about it, and you need to be able to get its relationships. So for example, what it can then use in your environment. Now, another thing is that you got to go beyond the cloud service provider. As we mentioned, you need to onboard things like your infrastructure as code. It's very relevant, and we're going to see exactly how. You need to onboard registries. They're also very relevant, and we're going to see exactly how. You need to onboard identity providers because they also contain identities that federate into your environment and also have access, right? So this seemingly simple step of just creating visibility actually got a lot more complicated, right? But this is the foundation for almost everything that we're going to talk about. And creating this kind of deep and clear understanding means a lot. Now, the next step is revealing security misconfiguration. So once we have a clear understanding of what we have in our environment, the next step is to understand what could be the problem. So analyzing the configurations, running them against policies that find things that are problematic, and revealing them, right? Also sounds pretty simple, right? But this spans from things that are very, how you call low-hanging fruit for attackers. Who can think of a low-hanging fruit in an environment that is a poor configuration? Okay, I'm going to give you an example. So who uses CIEM users? Okay, very few people. Very good, okay, because CIEM users are not a best practice, to say the least. So CIEM users have a feature called access keys. And access keys are a very dangerous thing to use, let's put it this way, because they're very prone to leakage, right? They're just two strings that give access to the CIEM users. Now, the way it works is, developers, for example, they put them in code repositories, they put them in public resources, they share them around. You never know who has access to them, and that's kind of problematic, right? So much so that if you actually try to create an access key today, the console will try to actively talk you out of it, right? It will ask you, okay, what's the use case of the access key? And based on what you select, it will kind of ask you, okay, maybe consider this, right? Maybe use this alternative. Now, an access key has a lot of policies relevant to it. So for example, if it's not rotated every once in a while, then a good security solution will tell you you have a very old access key. But there are also other things that might seem obvious, which are not so much so. Another poor security configuration is a public resource. So who here can tell me if this bucket policy actually configures the bucket to be public? Yes or no? Who thinks yes? Who thinks no? OK, so if you look here, the principal is AWS star. Now, what a lot of people think is that AWS star, when you configure it in a policy, means all the identities within my account. But that's not true. It's all the identities, period, right? So this explains why we see in the wild a lot of public resources. This is, for example, for S3, which is, again, a very bad misconfiguration because it potentially exposes data. But it can also happen for a lot of other different things that have resource policies. Now, a good security solution in that aspect will allow you to have access to those low-hanging fruits. For example, discovering your access keys, looking clearly at public resources, also looking at resources that may expose secrets. A lot of people configure secrets, for example, in environment variables of Lambda or in user data of EC2. And one of the things that we make ourselves, that we're proud of the most is our ability to be actionable. So a very popular widget that we have in our solution is if you only have 5 minutes, which will reveal the top things that you might want to deal with if you only have a limited amount of time, which you probably do. Now, the thing is that configurations can span from those low-hanging, very clear-cut issues to policies that are also very complicated. We mentioned Kubernetes. So Kubernetes have their own policies, right? So what a good security solution, what a good CNAPP solution needs to do is also look into configuration and policies relevant to Kubernetes clusters and show them to you in plain English and make sure you understand what is it that's exactly problematic, because there are its own policies. For example, running containers in privileged mode, right? That is also something that needs to be picked up on. Now, the next step, which is one of the most important ones, is controlling identities and their entitlements. So this is, as we mentioned, arguably the most significant relationship between resources, because what it basically entails is what each resource or each identity, either for a person or for a service, can actually do. Now, there are low-hanging fruit here as well. So for example, what you want to be able to see clearly are the third parties in your environment, where you have admin-level users, where you have users that may not be admin but can privilege escalate. Right? They can perform actions that will give them more permissions. Which users have access to classified data? Right? We're going to talk about that soon as well. And you also want to find identities that are inactive, right? To make sure you have better hygiene of identities in your environment. Now, another thing that you want to be able to do is monitor identities. If you can't retire them responsibly, and we're going to talk about that later, you want to be able to at least put monitoring on them. So let's say you have access keys in your environment, and you can't confidently say no one is using that access key anymore. What you want to be able to do is put in place a monitor service that will alert you if the IAM user is actually being used. Now, the holy grail of managing identities and their entitlements is achieving something called least privilege. Now, I assume you are familiar with the concept of least privilege, each identity just having what it needs to have. So if or when there's a breach, then the scope of that breach is limited. But this is something that is easier said than done. So this is the policy evaluation diagram that was relevant until very recently AWS released something called resource control policies, which basically answers the question, will the requests being made by an identity be answered with a yes or a no? Now, about a month ago, AWS released something called resource control policies, and this actually changed. If you think this is complicated, This is actually how it looks now. But this is just one part of it. The second part is this, right? So that diagram actually got a little bit more complicated. Now, you may think that's a bad thing, but I think it's actually a good thing because this is an embellishment of the kind of controls that you have in AWS in order to control the access that identities have, right? So this is basically a list of the different kinds of tools that you can use in order to create guardrails and to create boundaries and make sure that there is no unintended access. However, it does make it very hard to control, right? And you need to have expertise in order to understand what access is actually active and relevant. Now, if you want to be able to get to least privilege access, that is also very difficult. Because if you think about it, let's say that you have a workload and you have to attach it with a policy. How do you determine what access exactly, to what resources and to what actions it needs to get? I bet that even if you go and ask the developer itself, that probably knows the AWS service better than you do, give me a list of all the actions that your code is going to perform, and we're going to put it in a policy, and that's what we're going to give to the workload. That's not going to happen, right? It's going to be very hard even for the developer to do, and especially for you who may not know the code. Now, the nice thing about code is that it has a structured process of getting from the developer to production. And what a good CNAPP solution can actually enable you to do is to leverage that process. So for example, what we can do is run in your development environment where you can give the workload a more, I would say, lax, also not admin, but a more lax permission policy, and then look at what the code actually performs based on the logs, analyze that, and generate a policy which is least privilege based on the activity of the workload, and on demand, generate it, and then roll it up to production. Sure, after you test it, that it actually works. And this is what it actually looks like. So we have a workload, and it's been running for a while in its testing phase. Now, what we're going to do is, and we added it with Amazon S3 full access, because we don't know what it does and on what buckets. And now we're going to generate on demand, based on the last 30 days of activity, the policy that it actually needs. And now we can take this least privilege policy and apply it, right? And we're still in the controlling and managing. Right. Now, this is great for workloads, right? For services that are working on a structured code that also has a structured process of how it changes. But what do we do with people? People can't get the exact kind of access because we don't know what exactly they're going to do. Right? We can do a best effort by giving them policies based on their roles, but it will never be exact. So in order to limit the potential damage from a human user being breached, what we provide is just-in-time access. So what this allows us is to control the access in the dimension of time. So the way it works is if you have a user that needs access to a sensitive environment, it gets access based on a request for a business justification. So the user signs in using the identity provider and identity center. It then requests access from Tenable, which then goes to the approver. The approver approves the access, and then Tenable generates the access ad hoc for that specific business justification. And in a few hours, based on the definition, once the session is over, the access goes away. Now, there's also interface with third parties that make for a seamless process for that exactly. Now, this is what it looks like. So this is Tenable, where what we're going to do is we're not going to give access to the user. We're going to just create something called an eligibility. Eligibility is the permission to request access to a certain policy for a certain account. So here, for example, we're going to give access to 2 accounts, and we're going to give admin access. Right? Of course, this is not actually granting the access. This is just giving the permission to ask for the access. We are defining the requester and the approver, to which this will apply to. And now the requester can go into the console and actually request the access for 1 hour, specify the business justification, generate the request, and the approver sees the request and can now go and approve it or reject it. Now, from the console of the requester, they can actually go in and use the AWS account. Now, I know what you may be thinking. And of course, if we want to revoke the session, we actually can do that before it's over. But I know what you may be thinking. And do we really need another pane of glass and make it so that the developer has to go through hurdles in order to get an access? And of course not. And for that exact reason, we created a Slack integration or a messaging system integration, depends on what you have, which basically allows to do this process directly from Slack. So the user simply gives a command, /Tenable JIT, and it opens up the same kind of interface. And the approver can also approve the request from Slack itself as well. And on the same thread of the request that was made, the approval is granted, and access can be generated using a link to the environment, which is really cool. Now, another thing that this allows to do is actually audit what happened during the session. Because once there's a limited time and a limited scope and for a specific need, we can actually review the logs of each session and see exactly what happened. So here, for example, we can see that some kind of bad things happened during the session. So the user created an IAM user and then actually created an access key with permanent access to it, which is not something that you want, and you may want to ask the user some questions. OK, great. So this is about managing and controlling identities and their entitlements. Now, number 4 is vulnerabilities. So you're running workloads. Those workloads have code on them. They're using libraries. They're running on operating systems. Those things have vulnerabilities. Tenable is one of the most trusted and probably well-known names in vulnerability management. Of course, this is something that is applied to our cloud security solution as well. And one way to look at it is if we consider, for example, how containers are pushed from the developers developing them into production, right, through this process. You may know this or something like this, where the developer writes code. From the code repository, an image is created and then tested. If the tests succeed, it goes into a repository in production, and from there it goes to runtime. And really, there's a question of where you scan for vulnerabilities in this process, right? Because you want to be able, as part of this process, to detect whether or not the software is exposed to vulnerabilities. So the question is, where do you do it? Do you do it in the testing phase? Do you do it in the repository itself when it's in production? Or do you look at it at runtime? What do you think? So I think this gentleman got it right, because the answer is yes. You do it everywhere, right? That's the best practice. And the reason for that is that code might get not through this process. A developer might find a way to get it in someplace else, not through the testing. So that might not be enough. Or if you only scan in the repository of production, then it might come from a different repository. And if you only scan at runtime, then it might be too late, right? So you need the combination of all of these things, and that's a very big challenge when it comes to vulnerability management, because you then have to take this information of vulnerabilities from all the sources and make sense of it. Now, for this exact reason, our solution, the one solution, actually supports doing the scanning throughout all of these stages. So, for example, you can scan it during the build process by adding this call to our API from the build step. And you can actually put a flag that will stop the build in case a vulnerability of a certain criticality was found. and this is what it looks like. You can also scan using our solution in a repository, whether it's in ECR or by the interface that we have with your environment, or not ECR, right? If your repository is outside of the account, you can also onboard it based on the support of the different kind of repositories. Now, you can also do it in runtime, right, based on snapshot scanning. Now, the thing is about this, and why this is so valuable, is that you get the exact same look and feel for all the vulnerability scanning that you do. So for example, here we can see that we have AWS accounts as well as on-prem accounts. Because another way in which you can scan for vulnerabilities is using our on-prem agent. For example, if you're running a Kubernetes cluster on-prem, you can then use our agent in order to scan vulnerabilities there, and you get the results into one place. Now, this is what it looks like, for example, for on-prem scanning. This is what it looks like for virtual machines. And this is what it looks like for containers, right? It's in the same place. It looks it has the same look and feel. And the really interesting thing, because this is not just a standalone solution, this can be part of Tenable One. If you have Tenable Vulnerability Management, you can then get access from Tenable Cloud Security to Tenable Vulnerability Management and get intelligence about this vulnerability that was found. So let's say you now need to deal with a new vulnerability that everyone is talking about, and you need to scan all your environment and use the intelligence about it. You can scan it in all of these different locations, get all the results into one place, and then go into Tenable Vulnerability Management and get this information. Now, the next step is classifying data. What determines very significantly how much a risk is in what kind of access an attacker can get if it exploits it. And that, of course, very much revolves around data. For that reason, a few months ago, Tenable acquired a company called Eureka, which is a data security posture management solution. And we've already integrated it in a similar solution. It's not like the same login, but really two systems. It's the same thing. And I'm going to show it to you as part of our solution. We're integrated into our platform. Now, one thing that I didn't mention before when we talked about entitlement management is a feature called permission query. So what Tenable allows you to do is run very complicated queries in a very simple way under permission. So for example, if I were to ask you which identities in your development account have access to resources in your production account, what would you do? Well, it's hard to do it with the naked eye, but here we just choose identities in the development account. We look for resources in the production account. But now, because we also have a component that can classify the data in our accounts, we can also add to that query, OK, show me what access from this actually applies to, for example, digital identities, or applies to financial information, or applies to PII. And then I actually filter, and I can see on the one hand the identities, and on the other hand the data. And I can then go and deep dive into the data. I can see what kind of data it is. I can see the files where it's at. I can see examples for the sensitive data. And I just made a very complicated query. Imagine if I were to ask you again, show me identities in your development account that have access to resources in your production account, and that access allows them access to PII. That would be very complicated, but we just did it in a few seconds. Now, we're actually starting to move there a little bit more quickly because we built a very good foundation in the previous steps. So next up, and this is really where we kind of pivot, because this is a very significant part of the CNAPP journey, and that is contextualization and prioritization. Probably one of the most important parts of understanding what kind of risk we have is understanding context. And this is really the main potential that we have in our CNAPP solutions, because a path for an attacker usually isn't just one thing going wrong. It usually isn't just one thing that is configured poorly. It could be. It could be. You could, for example, configure a public bucket, and someone finds that public bucket and gets access from it. OK. But usually it's a misconfiguration, for example, combined with a vulnerability on the workload that allows to compromise it, and it has overprivileged access that will eventually give it access to data, something like that. Now, this is exactly why, by the way, the CNAPP category was kind of created. This is exactly why we now have platforms for managing our risk in the cloud. And this is the opportunity of getting all that information into one place and analyzing it and creating something that's called context. Now, the way we treat it is we have a very nice widget, which is arguably my favorite, that's called toxic combinations. And what toxic combination really is the fuse of information from all those multiple domains that we talked about, and that's why it was important to discuss them before we got here, and understanding where there's a combination that can create such a path for an attacker. So for example, one thing that you can see is where you have public workloads, that is, they're public to the internet, they have critical vulnerabilities on them, and they have high privileges. That is exactly what attackers are looking for, and where you should probably focus your attention. Now, another thing that is enabled to do with all that visibility that we have when we look at different kinds of risks is understanding the full context of it. So when you open a finding, a good CNAPP platform would actually explain, again, in plain English, with links to the resources it then discusses and the relationships of what is the exact context that made this finding a finding and made its criticality. For example, why is it critical? It's because it has a combination of different things that make it so. Right? If there's a critical vulnerability, but it's in some place where it can't be leveraged, maybe you need to address something else. Right? Maybe something else would pose more risk. Of course, treat everything, but again, do it on priority. Now, another thing, very significant, managing compliance. Eventually, I think one of the most popular demands that maybe every CISO needs to face is adhering to compliance standards, either for legal reasons, or for business reasons, or they want to meet best practices because that is what's expected from them. So what we do in that context is we take the most popular standards and best practices, and we actually contextualize everything that we find into the articles relevant for those findings. So you can get a clear assessment and, of course, generate a report, and you can do it periodically and see how you advance. That takes the finding or takes the failed resources of a policy and then converts that and explain what is that meaning in the context of your compliance. So you can see the overall, how you overall stack up to the compliance standard that you care about. And another thing that you can do, which is really cool in that aspect, is create your own reports, your own standards, and get the same kind of experience. Right? So let's say, for example, you specifically care about encryption in a certain environment. So you can take all the different policies that are relevant to encryption, build them into one policy, and then generate a report based on that and see what fails. Now, the next thing is strategizing how you're going to do remediation. Now, the reason why this is so important is that in cybersecurity, and I think this is something we all know, an ounce of prevention is sometimes worth even more than a pound or even a ton of mitigation. And the reason for that is that once you have a risky situation and you need to change something in order to fix it, for example, we talked about access keys, right? So you have an access key, you have permanent credentials in your environment that someone is now using, and you want to retire them, you want to replace them with something else. You need to be very clear and very sure that shutting them down won't shut down a business process, a legitimate business process, because the last thing a security person wants to do is create a denial of service on its own infrastructure. Another example of something that we saw is permissions. Let's say that you have an over-permissioned workload running in your environment. And what you, of course, want to do is you want to limit the permissions that it has. You want to reduce the kind of access that it has. But it could be kind of scary to do it, because if you do it and you take away permissions, then it might not work, right? So we address that specific aspect by creating an integration with the way that changes are made into environments that would reduce that kind of risk, right? And give you more control and allow you to make those changes in a more confident manner. So for example, of course, one of the things that, as we saw from before, we analyze the kind of access that every workload needs, and that's how we generated the policy on demand. Now, that can also be compared with the access that the workload has. So a very popular finding that we have in our platform is a workload that is overprivileged, that has too many permissions. Now, of course, the remediation for that would be applying the least privilege policy. But as we mentioned, that could get kind of scary. So what do? We integrate with the infrastructure as code. And what we are able to do is map the resource in your environment to the code that created it. Now, the reason why that is significant will be visible in a second. So here, for example, we have the toxic combinations panel right here. We're going to go to it. And this workload is overprivileged and public, et cetera, et cetera. We see a list of all the findings. And this is the information, this is the infrastructure as code that created it. Now, we're going to go into the overprivileged finding, right? The finding that indicates that it has too many permissions, right? You get the full context, you understand exactly what it accesses, what it doesn't access, and this is the policy that needs to replace the existing overprivileged policy. Now, here's what you can do. You can now create, this is the infrastructure as code, and this is the suggestion that we're making. So the suggestion would be to put in place this policy on the right with the green instead of this policy on the left, right? So this is the change that we're going to make to the infrastructure as code. Now, instead of making the change, which could be kind of scary, what we're going to allow the user to do is to create a pull request directly from a console that will simply suggest the change to be made. So this is the wizard. We are going to name the commit. Give it a message. And now we've created a pull request in the repository. There it is. And this pull request didn't actually change the infrastructure. It didn't change anything. It simply suggested to the person in charge of the infrastructure, which is usually not the security person, to make that change to the infrastructure as code, to change one policy, the over-permissive policy, with the least privilege policy. Now, this is significant because now the infrastructure person can test the pull request in a different branch, for example, and provision it to a development environment, run all the tests on it, see that the business functionality remains intact with the least privilege policy, and after all the tests are run, apply the change and reduce the permissions that the workload has. This is a very elegant process that really increases the confidence that the security person have in suggesting change. Because if the security person had to do it on their own, then they would have to go and actually generate the code themselves or figure out what to suggest, have discussions, right? This happens in seconds, the suggestion and then the tests. And as long as you have infrastructure as code and we can integrate with it, this is exactly what happens. Now, another way in which the platform can help remediate things is by looking at, running videos on PowerPoint is always a very unique experience. OK, so the next way in which our platform can actually support you in making those changes is, for example, if we talked about retiring access keys. So what you want to be able to do is you want to be able to track where an access key is being active. Now, one of our features that actually allows this to happen is our activity log. So here, in our identity intelligence, we can now go, for example, and find all the existing access keys. There they are. And we see one that's actually being used. Now, in the console of the resource, we have this tab right here called activity log. Oh, you don't see my cursor. So this is the activity log tab. It actually takes the CloudTrail and shows it to you in a very clear way. And one of the things that you can then see is from where calls were being made. For example, we can see this IP right here, and we can see that calls were made from it. Now, one thing that you can do if you have a platform that indexes all the things in your environment, you can take that IP, put it in the search box, and you will find the machine from which it's running. And then you can look at the machine, and you can actually see that the user data, which is the script that is run when the machine is loaded, actually uses the access key, and there it is. Right, so this is also an increase in your confidence as to look into where access keys are being used. And this supports the process, of course, of retiring them. And again, the video replayed. Now, next step, shifting your security left. This is already kind of, if you do that effectively, this is something that really shows a lot of maturity. And what shifting security left really means is, I assume you know it, is scanning infrastructure in the code phase before it's actually deployed. So before you actually provision resources, you can scan the code that generates them to find problem there and fix it. And of course, if you detected something, you can prevent the build. You can get the findings in a very clear manner. But there are actually two things that are really interesting that our solution does, which are really not trivial. One of these things is working with reusable components of code. So for example, if you're using Terraform, you can define or use modules. Right? Modules are reusable components. You just give them a different set of parameters, and then they provision the infrastructure in a different way. Which is, of course, a very, very best practice because, if you develop, I heard this actually today, if you develop the same thing twice, you kind of get it wrong 3 times. And if you use modules, then what actually happens is the code itself. For example, if you look at this piece of code down here, what actually happens is this code itself does not necessarily show you the problem because this is a module for provisioning a bucket. And as a parameter, it gets a definition of the ACL, which will determine, for example, if it will be public. Now, the instantiation of the module will determine that. So if someone only scans, if a security solution only scans the code of the module, they won't necessarily find the problem. Now, we secure the entire stack, and we're able to show you exactly where it comes from. Right? So we can see that what happened here, you don't see my cursor. OK, sorry. So we can see that that module was instantated, if you see it on top, with an ACL that is public read, right, on the top right. Now, a lot of security solutions, what they would do is they would simply scan the code of the module, and there's that. Right? They will show you, OK, this is a module. This is how it works. Okay, but they don't actually scan the actual instance. Now, another thing which is really interesting about infrastructure as code is that infrastructure as code itself can be malicious, right? This is something that not a lot of people know. So one of our researchers, Shelley Raban, actually did a proof of concept where she found that there are certain kinds of blocks. For example, this is the external data block in Terraform. And to make a long story short, what this actually does is it allows the user to configure an external program that will go and get data. So the code can actually call any program and make it go get data. Now, you understand how bad this can go, because this is basically code execution. Now, the interesting part about this is that this happens not only in the apply phase, but also in the plan phase. So what happens a lot of the time is that a developer will submit a pull request, and that pull request, in order to do it, the changes won't go through any kind of validation. And what this would mean is that they can make this kind of external data block, which will run code. And for example, what it would do is it will exfiltrate data. For example, exfiltrate sensitive credentials from your environment. And that will run in the plan phase. And you don't have to actually go and approve it. And what our solution, for example, does is actually find such blocks of code in your infrastructure as code. So, for example, if you have this in your pipeline, and you see that, as you see from line 21, that block, what it would do is it will actually trigger curl into exfiltrating a user password, which is something that might happen in an external module that a developer uses. What this would do is show you, okay, look, there's a problematic block of code here. Go and deal with it before you actually allow the user to submit the pull request, which will trigger a plan, which will run the code. Now, the last thing, which is a world of its own, is automated remediation. So what automated remediation means is that you want to be able, from the configuration of your platform, you want to be able to not just have the finding or the remediation recommendation, but you also want to be able to treat it. So for that, we have a bunch of integrations where you see a finding, you can actually go and click on the right, and even manually, for example, create a ticket for that finding, or send it by email, or even send it to a webhook. Now, another thing that you can do, and again, this very much ranges based on the level of maturity and how confident you are in your solutions, you can actually create an automation around this, right? So let's say that you have a webhook, and that webhook is something that you send the finding to. It takes the data about the finding, processes it, and resolves the issue automatically. If you can be confident that once a certain criteria is met and a certain set of conditions are filled, then you can send it to the webhook, you can create an automation around it, right? So this is really kind of the crown when it comes to your strategy, if you are able to do this kind of automation, right? And there are various levels of maturity for it, and this is really kind of like the last pillar of looking into your security solution in the CNAPP platform. Now, those are the 10 steps, but at Tenable, we believe in over-deliver. So I want to mention just one more thing, and that is that your environment or your infrastructure usually isn't just the cloud. And for that reason, the significance of our cloud solution being part of our platform, Tenable One, really means a lot. So Tenable One is actually a set of tools for exposure management of different kinds. And it really rolls up into a platform called Tenable One that can take information from all of these different components and then analyze it together. So you get like mega taxa combinations, right? Now, where this can be, for example, interesting in the cloud is that you can understand attack paths from one set of your infrastructure to your cloud environment. So I talk about access keys a lot because I have a vendetta against access keys and the kind of security risks that they create. So I can give this example as well. Now, an access key needs to reside somewhere. And a lot of the times, it resides on local endpoints, right, which are not in the cloud. They're on the desk, right? They're the machine. So, or they're virtualized maybe locally, right? They could be virtualized in the cloud, but they could be the laptop of your user. Now, what a lot of time happened is the developer would take access keys, and they would put them in environment variables on their machines. Now, malware creators actually know this, and there's malware crafted specifically for harvesting it. And what we can show you is a path, and this is what's illustrated here. We can show you a path from the detection of those access keys on the machine of the developer from a tool that we have called vulnerability management, which would run there. And the other half is the IAM user to which that access key belongs, the policy that it has, the data that can be accessed by that policy, and how sensitive it is. So this entire path is a vivid path from the machine where the access key resides to the actual data to which it gives access. Right? And this is the significance of using a platform that isn't only cloud security, but also includes other components. So to sum up, in the cloud, we have a huge opportunity when it comes to security, right? We can achieve, and I haven't done cloud my entire career, just in the past few years, and the opportunity is amazing because what we can do with the kind of analysis that a CNAPP platform has is amazing. But it's also very challenging, and this is exactly why a platform like this means a lot. Context is probably the most significant thing, and you need to use it to your advantage. And this is exactly what CNAPP platforms are for, right? They can help you gain insights across those domains and fusing information together. And using context, you can understand exactly what needs your focus. Now, remember that you have infrastructure outside of your cloud as well, and you need to take that into account. So if you want to learn more, and you can speed to the expo that I think closes at 4, which is in about an hour, you can meet us at our booth, but if you probably won't do that, you can reach out for a demo for your environment. So I really do want to thank you. This is a tough spot Thursday afternoon, and you stuck around for an hour to hear me talk about cloud security. So I really want to thank you for your attention, and I am out of time, but I'm going to stick around here if anyone has any questions. So thank you again.